Hi, my name is Daniel Rosbach, and I'm going to be giving a presentation over Eigrp stub routing. I'll be using Lab 2.2 from the list of labs that we are doing in our Cisco Advanced Routing class. I hope you enjoy it. So first off, what is Eigrp routing? So a little definition of Eigrp is that it's an advanced distance vector routing. So a decent definition of Eigrp is that it's an advanced distance vector routing protocol designed by Cisco. So what exactly does that mean? Eigrp is basically just another routing protocol that's more efficient than, let's say, OSPF. Eigrp allows you to kind of limit the traffic that routers are going to be sending to each other. So what are the benefits of Eigrp? So Eigrp allows for fast convergence when there's changes on the routing tables within the routers. Variable subnet length, so you can have routers that have different subnets and different IPs, and they support for partial updates. All this becomes unlocked when you don't have to transfer your routing tables across 50 routers when you have a big campus. How do you configure Eigrp? Well, in our first command, router Eigrp 100, we're using 100 for our autonomous system number. And this opens the Eigrp interface. Our next command is network 172.16.0.0. This is just our IP of our first router. Next we have network 192.168.1.100. This is just the second IP of our router. As you can see, it's pretty simple to configure Eigrp. It's much more of a concept knowledge base than it is something that's hard to apply. But you definitely want to know what you're doing before you apply these commands. If you didn't quite understand the example, you can check out the pages 64 and 65 in our advanced routing book that we've been using in our class thus far. So we learned what Eigrp routing is, but we didn't really learn what stub routing is. So a decent definition of stub routing is it's the Eigrp routing feature that allows you to limit query messages within the network. Routers configured as stubs do not forward Eigrp lured routes to other neighbors. So this is an efficient method for limiting the query range of routing tables. Now that was probably kind of fast and a lot of words, so what does that really mean? Well, stub routing is a little bit different than normal Eigrp. I'm going to take that out. I'm just going to skip out what does this mean. What are the benefits of stub routing? So in order to really understand why you configure stub routing and not just Eigrp, you have to look at how efficient it is. You see how low cost of resources, and most importantly, all this is possible because you're able to put more control over the routing data exchanges. So how do you configure Eigrp routing? It's pretty similar to just configuring Eigrp. Our first command is router Eigrp X. X is representing our autonomous number. In the last example, we use 100. Our next command is network, then our IP address of our router. Once again, we're using a second router here. So we have network and then the IP of our router. And then you want to stick each one of these in the Eigrp stub setting using the Eigrp stub command. I just pulled this example from the Cisco Commands website. It's pretty simple. If you go to their website, I just pulled this example from the Cisco Commands website. It's available if you need to check out and don't quite understand this example either. So now we really get to why you would use stub routing. The lab really didn't mention anything about the options that you could go into. It just showed the basic configurations of Eigrp stub routing. So first, our option is receive only. This would restrict an Eigrp stub router from advertising any route to other routers. Next, we have connected. This allows an Eigrp stub router to advertise its connected networks. Next, we have static. This allows an Eigrp stub router to advertise its static routes. Summary. This allows an Eigrp stub router to advertise its summary routes. It's important to know that this is the default option. So if you go in, just like our example, and you stick your router IP into Eigrp stub, then you're going to follow the summary option. Last, we have redistributed. This allows an Eigrp stub router to advertise external Eigrp routes learned from other routing protocols. It's an important note to take that if you already have Eigrp stub configured, you're going to be sitting in that summary option. And if you decide that one of these other options is more enticing to your network and you change it, it's going to break all of your Eigrp relationships. So you're going to have to configure all of those routers over again. And if you're not taking this into account, it might result in some network downtime. Now that we have a good understanding of what Eigrp routing and Eigrp stub routing are, let's go ahead and dive into Lab 2.2. So unfortunately, the first part of this lab is me resetting the routers. I did the whole entire lab and I thought I was recording. So it is good to note that if you do mess up on one of these labs, you probably did not save the running config, and all you got to do is reboot them so you can start over. Kind of the unfortunate thing about me doing the lab already was I was pretty frustrated that it didn't record, and I tried to rush through it. You're going to see some troubleshooting from me because of that. I just wanted to get through the lab, and I was pretty irritated that I didn't record the first time. The first thing that I always do is name the routers. Here I name them R1, R2, R3. It represents just in the lab topology. I also like to line them up in 1, 2, and 3 so I never get them mixed up. For this lab, you can see that I use the no logging console command. What this command does is turn off all those extra console lines that it tells you that interface GE0 has changed the state from down to up, or just some actual good information. Since I've done this lab before and this is just a lab scenario, I'm going to go ahead and turn it off so I'm not bothered by it. Our first step of the lab is pretty simple. It just has us stick the interfaces of the routers with the correct IP address and subnet masks and turn them on to make sure that we don't have any issues down the road. Best set is clock rate for the serial interfaces. On the DCE ends, you always want to set your clock rate to 64,000. Some of the most important IP addresses in this lab consist of the loopback addresses because we are configuring Eigrp stub routing. A loopback interface is not a physical interface. It's kind of more of a theoretical interface, and it just kind of helps us organize and group for EIGRP. I'm just going to go ahead and skip over myself putting all these IP addresses in there. It's pretty boring to watch, and you guys aren't going to really learn anything from it. Once we've made it through putting all of our IP addresses in, we're going to go ahead and use the show IP in brief command. This is just going to show all of your configured interfaces on your router. Super useful command. I can't harp enough how important these show commands are when you're doing labs and you're actually doing work in the real world. Finally, we've made it to the point in our lab where we can start configuring EIGRP. Similar to the example that I used in the PowerPoint presentation, it's router EIGRP 100. 100 once again is our autonomous number to separate and stick all of the routers that we want in this group in the 100 autonomous number. Next we have network 10.0.0.0. Once we get R1 configured, we can move over to R2. Our first command, similar to R1, is router EIGRP 100. You can see that router 1 and router 2 are going to be in the same EIGRP group. Also, we're going to use the same command, network 10.0.0.0. Finally, this is the point where we change our configuration from router 1 to router 2. This command is network 192.168.0.0 space 0.0 space 255.255. These are just kind of the basic configurations of EIGRP. The commands above are going to stick all of the interfaces on R1 and R2 in EIGRP 100. This is going to allow us to dig deeper into the configurations once this is done. Next, we're going to summarize R2's loopback interface in its EIGRP update to R1 using manual summarization. The command for that is interface serial 0/0/0. And then the next command is IP summary -address space EIGRP 100 for our autonomous group, and 192.168.0.0 space 255.255.248.0. Our next command has more to do with telling the data to go a certain direction. So we're going to configure a static route on R2 to R3's LAN, and configure a default static route on R3 forwarding all traffic to R2. Those commands are IP route space 10.1.5.0 and the subnet mask 255.255.255.0 space 10.4.4.2. Then our next command is IP route space 0.0.0.0, then another 0.0.0.0, and then the route 10.4.4.1. If you were paying attention earlier in the lab, you noticed that 10.4.4.1 was the DCE serial port on R2. And then if you're paying even more attention, you noticed that the 10.4.4.2 is the normal serial interface on R3. After we get those static routes set, we're going to want to go ahead and ping to make sure we haven't made any user errors so far. The ping commands are very similar to the run commands. These things will save your life and will make sure that you're doing things right. Now, if you were like me and were frustrated and were rushing to the lab, you probably had an error. So I'm going to go back and troubleshoot what I did wrong thus far. Now that I got everything sorted out, I'm going to move on to some show commands. Once again, these show commands are awesome. So show IP Eigrp neighbors. So this is just showing your Eigrp neighbors. And if you've done it right, it should show the neighbor 10.2.2.1 on the serial interface 0/0/0. At this point, we have Eigrp routing configured. But if you remember, this lab is Eigrp stub routing. So next we have to complete the stub routing configurations. Our first command, very similar to setting up Eigrp, is we want to go into that 100 autonomous interface. Once we're there with the command router Eigrp space 100, we're going to use Eigrp space stub space question mark. Now you can see that the router is going to show you all of those options that we went over earlier. Now something that I don't really like about the lab is this is the only thing that they say about it. And in the lab they keep it basic. So we are in that summary option. Once again, I'm just going to tell you what that summary route is so you don't have to skip back in the video if you forgot. Summary allows an Eigrp stub router to advertise its summary routes. This is always the default option. If you configure stub routing, this is what you're going to get. Now that we have configured the super complicated Eigrp stub, we need to confirm that we did it right. Let's use a show command, which is show space running dash config space break space section space Eigrp. This is going to show all of your EIG configuration information. And at the bottom of it, you can see that Eigrp is connected and set to summary if you did it right. At this point in the lab, you're going to see me going through some of those awesome show commands that are really going to dive deep into the details of what we've configured to make sure that we have it right. Finally, let's do some pinging to make sure that we did configure everything right. Even if our show information is correct, we need to double check with our pings. So I'm going to go ahead and ping 10.1.5.1 from R1 and 10.1.1.1 from R3. Now that I finally got everything going, we are going to change it to receive only, which is one of those options that I mentioned earlier. I have said a couple times that this lab didn't really dive too deep into the options. It does cover receive only, but I really would have liked some of those other options to be in here. So if we are configuring stub receive only, we're going to go back into that 100 autonomous interface. And we're going to use the command Eigrp space stub space receive dash only to set our stub routing to receive only. We've covered a lot, so you probably don't remember what receive only is. So I'm going to remind you here. Eigrp receive only. This restricts an Eigrp stub router from advertising any route to other routers. This is the most locked down option that is going to be the most efficient for your network. A lot of people would say this isn't the most useful command, but if you have some limited resources and you have to have Eigrp enabled, this is probably the option that you're looking for. After a couple more show commands to make sure that our neighbors are correct, and we're on receive only peer advertising, now we're at the point of the lab where it's finally done. You should be able to look at the end of the lab and issue the rest of those show commands just to make sure that you have everything correct and you have your Eigrp stub routing configurations right. At this point, I don't have any more information to give you on Eigrp stub routing. Thank you so much for taking time out of your day to watch my presentation. I hope you have a fantastic rest of your day.